A doctor discovered how to stop mothers from dying. His colleagues mocked him, locked him away, and he died of the very infection he spent his life trying to prevent. That was only the beginning. Every few decades, one person changes everything. Not an army, not a government, not a billion-dollar corporation. One person, usually ignored, often ridiculed, sometimes destroyed, and then proven right. This has happened more times than you know, and almost every time the history books got the story wrong. My name is Darwin, and I was there. I have spent more time in laboratories than any creature alive. I have watched brilliant minds be laughed out of conference rooms. I have seen cures dismissed as nonsense. I have watched the wrong people take credit and the right people take none. And I have decided it is time to set the record straight. Welcome to the Lab Rat Chronicles. I am your host. And before we are done here tonight, you will never look at medicine, science, or the word expert quite the same way again. Let me ask you something. When you think of medical breakthroughs, what comes to mind? A scientist in a gleaming white laboratory. Careful, methodical experiments, peer review, scientific consensus, and then eventually a triumphant press conference where the world celebrates the discovery. That is a beautiful story. It is also almost entirely fiction. The actual history of medicine looks considerably messier. It looks like a Hungarian physician named Ignaz Semmelweis losing his mind in a Vienna asylum because no one would listen to him. It looks like a gastroenterologist named Barry Marshall drinking a solution containing Helicobacter pylori to win an argument with the global medical establishment. It looks like a biochemist named Alice Ball, 23 years old, working at the University of Hawaii, developing the first effective treatment for leprosy, watching her work published under another man's name after her death. The history of medicine is not a story of orderly progress. It is a story of human stubbornness, institutional arrogance, political interference, and occasional accidental genius. And it is the most fascinating story in human history. That is what we do here. To understand how medicine works and how it fails, we need to start at the beginning. Not the very beginning. I am old, but I have my limits. Let us start in ancient Egypt. Around 1600 BC, a document called the Ebers Papyrus described over 700 medicinal compounds. Willow bark for pain, moldy bread applied to infected wounds, garlic for cardiovascular conditions. Now here is the remarkable thing. Willow bark contains salicylic acid, the active compound in aspirin, later synthesized and commercialized by Bayer AG in 1899. Moldy bread was applied to infected wounds, a remedy that sometimes worked, though nobody knew why. 3,000 years later, when Alexander Fleming identified Penicillium notatum at St. Mary's Hospital, London, medicine finally had an answer. And garlic contains allicin, a compound with measurable effects on cardiovascular health that modern pharmacology is still studying. The ancient Egyptians did not know why these things worked, but they worked. And then, for roughly the next 2,000 years, much of that practical knowledge was buried under theoretical frameworks that sounded more sophisticated but were considerably less effective. The ancient Greeks gave us the four humours: blood, phlegm, yellow bile, and black bile. According to Hippocratic medicine, if you were ill, one of your humours was out of balance. The standard treatment was bloodletting, removing blood from the body of a person who was already critically ill. This approach dominated Western medicine for nearly 2,000 years. 2,000 years! Think about that the next time someone tells you that scientific consensus is always correct. I want to be precise here. I am not telling you that ancient medicine was foolish and modern medicine is perfect. I am telling you something more interesting. I am telling you that educated, well-intentioned physicians have been confidently wrong about infectious disease transmission for most of human history, and that the people who figured out the truth were almost never celebrated in their own time. This pattern, and I have watched it repeat more times than I can count, is the central story of medical progress. Remember that. We will come back to it.
By the middle of the 19th century, medicine was at a crossroads. Vienna General Hospital, the Allgemeines Krankenhaus der Stadt Wien, had a problem, a catastrophic one. Women were dying at alarming rates in the first obstetrical clinic maternity ward. The condition was called puerperal fever, also known as childbed fever or postpartum sepsis. And it was killing somewhere between 10 and 35% of women who gave birth in hospital maternity wards across Europe. The accepted explanation was miasma theory, the idea that infectious disease transmission occurred through foul-smelling vapors rising from decomposing organic matter. Bad air. That was the prevailing scientific consensus. Then a young physician named Ignaz Semmelweis, working at Vienna General Hospital in 1847, noticed something. Women who gave birth on the street, outside the hospital, sometimes in alleyways, had dramatically lower maternal mortality rates than women who gave birth inside the first obstetrical clinic. The clinic, staffed by physicians and medical students, had a death rate roughly 5 times higher than the adjacent clinic staffed by midwives. Semmelweis investigated. He found that physicians in his clinic moved directly from performing cadaveric autopsies to delivering babies, without washing their hands, without changing their clothing. He introduced mandatory hand washing with chlorinated lime solution, calcium hypochlorite, for all physicians and medical students entering the maternity ward. The maternal mortality rate dropped from approximately 18% to under 2%, almost immediately. Ignaz Semmelweis had just made one of the most consequential discoveries in the history of infectious disease transmission. The response from the European medical establishment? Colleagues dismissed his findings. Senior physicians at Vienna General Hospital were offended at the implication that a physician's hands could transmit disease. One prominent critic, Carl Edvard Marius Levy at the University of Copenhagen, published a formal rebuttal arguing that the statistical evidence was insufficient. Semmelweis grew increasingly desperate. He published his major work, Etiology, Concept and Prophylaxis of Childbed Fever, in 1861. He wrote open letters. He argued publicly with anyone who would engage him. In 1865, Ignaz Semmelweis was committed to the Landesirrenanstalt Döbling, the provincial asylum in Vienna's Döbling district. He died 14 days later. He was 47 years old. The cause of death was pyemia, bloodstream infection. The autopsy confirmed the infection entered through wounds on his right hand, injuries historians believe were sustained during his violent committal. 2 decades after his death, Louis Pasteur's germ theory of disease and Joseph Lister's antiseptic technique confirmed everything Semmelweis had discovered. The hand-washing protocols Semmelweis pioneered at Vienna General Hospital became standard practice in hospitals worldwide. Ignaz Semmelweis was right about everything. He did not live to know it.
I was in Vienna during those years. I watched it happen. And I will tell you what struck me most. It was not the cruelty of his colleagues, though that was considerable. It was how ordinary the resistance was. These were not evil men. They were educated, respected physicians who had built careers and identities around a particular understanding of infectious disease transmission. And when a young Hungarian physician told them they were wrong, told them they were, in fact, contributing to the maternal mortality rates of their own patients, they could not hear it. That is not a 19th century problem. That is a human problem.
September 1928, London. Alexander Fleming returned from a 2-week vacation to his bacteriology laboratory at St. Mary's Hospital, London. His workspace was famously, legendarily, untidy. And on his bench he found a petri dish he had left out before leaving. The dish had been contaminated by a mold, Penicillium notatum. And around the mold, the Staphylococcus aureus bacteria Fleming had been culturing were dead. A clear zone of bacterial inhibition surrounded the Penicillium notatum colony like a moat. Fleming examined it carefully and recognized he was looking at something extraordinary, an antibacterial substance being produced by the mold. He named it penicillin. He published his findings in the British Journal of Experimental Pathology in 1929. The global medical establishment showed almost no interest. For nearly a decade, penicillin existed in the scientific literature, documented, referenced, and almost entirely ignored. Fleming himself was unable to develop it into a stable, usable medicine, and eventually moved on to other research. It took a wartime crisis and 2 scientists at Oxford University, Howard Florey and Ernst Chain, to finally develop penicillin into a therapeutic agent in 1940 and 1941. The timing was critical. World War II Allied forces were suffering devastating casualties from wound sepsis, bacterial infections killing soldiers who had survived their initial injuries. The first human patient treated with purified penicillin was a British police constable named Albert Alexander, who, in February 1941, was dying from a severe Staphylococcus aureus and Streptococcus infection. He had already lost one eye to the spreading sepsis and had abscesses throughout his face and lungs. Within 24 hours of his first penicillin injection at the Radcliffe Infirmary in Oxford, Albert Alexander showed dramatic improvement. The research team ran out of penicillin before Alexander could fully recover. He died a month later. But the proof of concept was definitive. Within 2 years, the United States War Production Board coordinated mass production of penicillin. By the end of World War II, penicillin had reduced the mortality rate from bacterial infections among wounded soldiers by an estimated 15% and has saved an estimated 200 million lives in the decades since. Fleming, Florey and Chain shared the Nobel Prize in Physiology or Medicine in 1945. Fleming, who made the initial observation but was unable to develop the compound into a usable medicine, became the famous one. He was knighted. He received a hero's welcome on an American lecture tour. Howard Florey and Ernst Chain, who did the systematic scientific work of transforming a laboratory curiosity into a life-saving antibiotic, received considerably less public recognition. Science is not always fair about these things. By now you may be noticing a pattern. The breakthrough happens. The medical establishment resists. Time passes. The breakthrough is proven correct through randomized controlled trials or overwhelming epidemiological evidence. Credit flows to someone other than the person who deserved it, and a clean, simplified version of the story gets written for the history books. I have watched this happen with germ theory of disease, with hand-washing and maternal mortality, with penicillium notatum and antibiotic therapy, with Peyton Rouse, who proved viruses cause cancer at the Rockefeller Institute in 1911 and waited 55 years for the Nobel Prize in Physiology or Medicine, with Katalin Kariko at the University of Pennsylvania, who spent decades being defunded, demoted, and dismissed before her research into messenger RNA technology became the scientific foundation of the Moderna and Pfizer-BioNTech COVID-19 vaccines. And with a story about sucrose consumption and the dietary fat hypothesis, a conflict between nutritionist John Yudkin at Queen Elizabeth College London and epidemiologist Ansel Keys at the University of Minnesota, that shaped global dietary guidelines for 50 years and affected the metabolic health of hundreds of millions of people. That one we will cover in detail in a future episode. And I warn you, it will make you angry. But here is what I want you to take from tonight. Medical progress does not move in a straight line. It does not move at the pace of peer-reviewed evidence. It moves at the pace of human psychology, which is slow, defensive, and tribal. The people who change medicine are almost never the most powerful people in the room. They are usually the ones being ignored, mocked, or actively suppressed by the most powerful people in the room. And that means the history of medicine, the real history, not the sanitized version, is a story worth knowing, because it tells you something important about how scientific knowledge actually advances, about who gets to be called an expert, and who gets to decide when the experts are wrong, and occasionally about how one stubborn person with an inconvenient idea changes everything.
In the weeks ahead, we're going to go deep. We're going to talk about Barry Marshall, the gastroenterologist at Royal Perth Hospital who drank a solution containing Helicobacter pylori to prove to a global medical establishment that peptic ulcer disease was caused by bacterial infection, not stress. We are going to talk about the war between John Yudkin and Ansel Keys over the dietary fat hypothesis, a conflict that shaped the nutritional epidemiology guidelines your grandparents followed, that may have contributed to the modern metabolic disease epidemic, and that the sugar industry worked very hard to make sure you never heard about. We are going to talk about Alice Ball, the 23-year-old black chemist at the University of Hawaii who developed chalmugra oil injectable therapy, the first effective treatment for leprosy in 1915, and watched another man publish her work under his name after she died. We are going to talk about Francis Kelsey, the pharmacologist at the United States Food and Drug Administration, who single-handedly blocked thalidomide from entering the American market in 1961, defying pressure from pharmaceutical manufacturer Richardson Merrill, and in doing so, prevented thousands of American children from being born with severe limb reduction defects. And we are going to talk about Vivian Thomas, a carpenter's son with no medical degree who designed the Blaylock-Thomas-Taussig shunt, the surgical technique that saved infants born with tetralogy of Fallot and other cyanotic congenital heart defects, while cardiac surgeon Alfred Blaylock received the credit and the recognition for 25 years. These are not obscure stories. These are the stories behind medicine as we know it, and they have been waiting a long time to be told properly. I am Darwin, and I have been waiting considerably longer. Subscribe, because the next episode, the one about the gastroenterologist who drank the bacteria, is not a story you want to miss.
Semmelweis never received the recognition he deserved. We fixed that. The OG of handwashing. Link below. They never put my name in the paper, but I was there.